Hello everyone, welcome to Maans IAS here in Chandigarh. And as I've been teaching here the subject of science and technology, and I've mentioned about science tech developments in India and space technology development in India, we will continue further with our discussion. So in this session, we are going to discuss about launch vehicle technology. We are going to discuss about launch vehicles technology. So launch vehicles, right, is an important topic for the exam, and you can get question in the examination. So let us understand every aspect of launch vehicle. So theory part of it, application part of it, and I'll connect from the current dimensions, current affairs. So when you say launch vehicles, right, launch vehicle. So what is a launch vehicle? The first thing comes, what is a launch vehicle? A launch vehicle is a space rocket. To a ferry spacecraft, right? See, when we use the word spacecraft, satellite is also spacecraft, right? Or if you want to write it separately, for launching satellite or spacecraft, right? Or sometime could be crew module, like in the case of Gaganyaan mission of ISRO, India, we are going to place Indian astronaut inside a module, what is called crew module, that can be taken by a rocket or launch vehicle. So crew module, sometime could be something module to be docked, let's say building space station, where we can dock module one by one. That can be carried by a space rocket or launch vehicle, right? Crew module, etc. to the outer space, right? So we ferry that thing to the outer space. So the outer space becomes a very, very important from the perspective of this. And what the rocket will do, the launch vehicle will place that spacecraft or a satellite into a designated orbit around the Earth, right? So they're intended, a launch vehicle is intended to place or insert, right? A launch vehicle is intended to launch spacecraft into designated orbit. Now this orbit around the Earth, or it can be around moon of the Earth, like Chandrayaan mission, or it can be around other heavenly bodies, like let's say other planets, for example Mangalyaan, Mars, or it can be Jupiter, Saturn, or it can be asteroid, could be comet, even around the sun, solar observatory, it can be any kind of thing. So spacecrafts into designed orbit or designated orbit, where we have been designated orbit, we can place them. So that is what the rocket or launch vehicle technology play a crucial role there, right? That comes into very important one. Now generally when we look at launch vehicle, so if we look at the main aspect of the major components of a launch vehicle, any space rocket or launch vehicle, right, have first very important thing here, propulsion system or engine. Now there are different types of propulsion systems of a launch vehicle, and you know that commonly you have come across such word, thrust, booster, motor, right? But here when we say propulsion system, so they have been given the name, main name is this one, thruster, which provide thrust and take the launch vehicle to the outer space. To that was thruster. Sometimes there can be booster, right, which can enhance speed, boost the propulsion of such space vehicle or launch vehicle there. Now, depending on the type of engine what is used, you know that one of the very important thing which is required here, fuel, or what you call the propellant. Fuel or propellant. Now, fuel which is used can be in solid form, solid state, or liquid form, or in the liquid form also we come across cryogenic engine, which we are using right now, GSLV Mark II, Mark III in the upper third stage. So liquid hydrogen, liquid oxygen. So fuel propellant that is required here. For example, one is the HTPB, hydroxy tetra tetra polybutadiene. There's solid form, which we use in PSLV, Polar Satellite Launch Vehicle, and GSLV. Then comes here UDMH plus N2O4, unsymmetric dimethyl hydrogen, just like petrol, diesel, kerosene, or what we say monomethyl hydrogen, unsymmetric dimethyl hydrogen or monomethyl hydrogen burned with nitrogen tetroxide. That is a liquid fuel, right? Today we are using the second engine, second stage of both PSLV, Polar Satellite Launch Vehicle, and GSLV UDMH, and we have developed an engine called Vikas engine, right? So they are liquid in nature. Third very important thing comes about any space launch vehicle, that is in terms of payload. Now, what do you mean by payload? That is what it carries. You will see in the rocket upper part, the box, where the things are placed, satellites or a spacecraft or human crew module, whatever placed there, that is taken to the outer space and inserted into the orbit. So again, payload. The payload could be instrument, it can be satellite, it can be instruments, it can be onboard camera, it can be any kind of module, any kind of spacecraft. That can be payload. That what the launch vehicle carry. That what we can think of that, right? So it becomes very, very important from the exam point of view. So when you are writing answer, you have to bring this kind of points there. First, the definition. Second, about the launch vehicle. Now what I'm coming here, let us go to the next thing here. Classification, types of launch vehicle. So we can broadly divide launch vehicles into two categories, right? We can divide into two categories. The first category, what is called here, ELV, expendable launch vehicle, ELV, and second is reusable launch vehicle, RLV, right? Expendable launch vehicle, reusable launch vehicle, ELV and RLV. Now what is here? So it is very clear from the word, when you say expendable, expenditure, expend. Once it is used, it's over. Used only once for a space mission. These are conventional type of rocket. These are conventional rockets. And where they are generally used for launching satellites, right? Or any kind of a spacecraft and all this. So generally used for launching satellites. and spacecrafts, not for human space mission or human space flight. But we can use such kind of ELV for human space flight if we place or put inside astronauts in a module, what we call a human crew module. And just like a satellite, that crew module can be dropped into the orbit. So that is possibility. That is what possible. But generally it is used for satellites and spacecraft and those kind of launching there, right? That is what we use here. Now, what is another aspect of this? They use use of thrusters. Thrusters in various stages. There may be 3 stage, 4 stage, which stage is there? Like, just take an example. When you look at Polar Satellite Launch Vehicle PSLV, it's 4 stages. First stage engine thruster use solid fuel STPB. Second stage is a Vikas engine which use liquid fuel. Third stage again solid, and the last stage, fourth stage, is liquid. So this 4 thrusters, 4 phases, and again 2 types of fuel: solid, liquid. That is a PSLV. So that's what different thrusters for different stages are there, right? So here, when we take example here, so in our case, India's case, PSLV, even GSLV, Geosynchronous Satellite Launch Vehicle, they're designed only for once for a space program. That is over, right? So that's what they are called ELV. So we can place into this one. Then recently, ISRO has developed SSLV, Small Satellite Launch Vehicles, right? So that part comes here. Now, when you look at reusable launch vehicle, so from name it is very clear. They can be used again and again, reusable. So here, used for multiple, there are many space missions, because they are able to be recovered, reuse. That means they go into the space, come back. So again we can assemble and go for next mission. So that's what it comes here. So multiple space programs, space mission there. Now what is here? Their advanced rocket. Compared to ELV, they are advanced space rocket, right? And where we generally use for such kind of rocket here? Generally used for human space flight, manned mission. Generally used for human space flight or for manned mission. It takes an astronaut to the outer space and then bring them back safely to the Earth. What is something called space shuttle. It can go and come back. Shuttle, right? So there, there's used for manned missions here, right? For that. But in future, we can use the same type of rocket for launching satellites or spacecraft also. Imagine you have a rocket, RLV. Instead of human going to their outer space, you place satellites, and the RLV goes and launch the satellite, come back. Again, we can get ready for another mission, next mission. Today, when we use the normal ELV, it just goes stage wise, launch the satellite, is over. Hundreds and thousands of crores of rupees is gone. But when you look at RLV, same satellite what we are using for ELV, for RLV, satellite, it will go there, launch the satellite, come back. Again, we can ready for the next launch. So price or the total cost of the mission which ELV we have to spend will be here in RLV for satellite launch 1/10. It will become 1/10 of the cost of ELV. We will be able to launch even satellites, spacecrafts using RLV, reusable launch vehicle. That's possible. So here, there is possible there for manned mission there. So, but can also be used can also be designed to be used for launching satellites and spacecrafts. Basic theory is very, very important. Let's say when you get question in the exam, you must know the theory part. Now, what is the fourth point here? It does not use thrusters. It first goes like a rocket, boosters, and then comes with what is something called re-entry. When it comes back from the space, re-entry. So when it enters the atmosphere, it flies like a aeroplane or jet plane and land on a runway. It lands on a runway. So here, use of booster. Heavy boosters are used. Use of boosters with winged aircraft. Now this winged aircraft carry astronauts. Now if you look at examples here, worldwide if you look at, there are 3 countries, right? I'm talking government agencies which have got this kind of RLV technology, Reusable Launch Vehicle technology. Although now private companies like SpaceX, Elon Musk has come, Virgin Galactic, right? Another company, they are developing private space launch vehicle, RLV, to cater space tourism in the future. But now here, if you look at NASA has a space shuttle, but NASA has retired this space shuttle program, and NASA is now developing more advanced RLV. Initially, NASA, American Space Agency, developed 5 space shuttles: Discovery, Atlantis, Endeavour, Columbia, Challenger. Columbia and Challenger met with accidents, and remaining 3, Discovery, then Atlantis and Endeavour, they have been placed into museums, space museums in the USA. Now for moon mission of NASA, Artemis mission, where just like Apollo mission, Artemis mission's next phase will be landing man on the moon. Very similar to what NASA did earlier with the Apollo mission. The Artemis mission, it has developed a more advanced RLV called here Orion, New Orion spacecraft, right? But here, older one, space shuttle. Then second country is Russia, right? Russia has a Soyuz. The name is Soyuz. Like 1984, Soyuz T-11 took Indian astronaut, Indian Air Force, officer, squadron leader, Mr. Rakesh Sharma, into the outer space, and he came back. That was Russia support. You all know that the clip is there. That time Prime Minister Mrs. Indira Gandhi asked, right, Mr. Rakesh Sharma, how India looks from the space. So what he replied, "Sare jahan se acha Hindustan hamara," right? So that is 84. So he went by Soyuz T-11. That is a RLV of Russia. The agency name is Roscosmos. That is a Roscosmos. Now third country, government country, which has got the technology, that is China. Chinese Aeronautical Sciences, CAS, has Shenzhou. So Shenzhou is a RLV of China, right? Shenzhou is a RLV of China. Chinese Aeronautical Science, CAS. Now India is going to be the 4th country in the world to develop a RLV, and we are almost to the advanced stage. We have already done testing for landing experiment, Pushpak, that we have already done that. Now coming here, private company, you know that, SpaceX, Falcon 9 Heavy, that is the Elon Musk company, SpaceX. Falcon 9 Heavy, right? So first thing is that knowing the technology, what the technology is all about. And in one of the sessions earlier, I have already mentioned that, and even today I mentioned PSLV, GSLV, SSLV, this India Space Mission there, right? Now what is very important here, which I would like to add here, that is in terms of if you look at India's launch vehicles, particularly traditional launch vehicles, PSLV, Polar Satellite Launch Vehicle. Polar Satellite Launch Vehicle. What are the basic features? What are configuration? Sometimes question can be asked, short question, right, about PSLV. So if you look at here PSLV, if I show you the design here, I mentioned that it's a 4-stage rocket, 4 engines are there. Our first stage that uses solid fuel. Our second stage, that is a liquid engine, Vikas engine. Then again solid, again liquid, and this is where we have our tricolor Tiranga, the box where we keep all the satellite there, right? So we always count from the bottom. This is the first stage. This is second stage. Second stage engine. Then comes third stage. Then the last comes fourth stage. Now this liquid engine, second, fourth stage, that's called Vikas engine. LPSC, Liquid Propulsion System Center, has developed that. Now here at the top, we have a satellite bus where we keep satellite, spacecraft, everything here. Now let's understand other features of PSLV. So when you say PSLV, right, it was designed, right? You primarily, primarily designed designed to be used for what? Polar satellite. To launch Earth observation. Earth observation, what we call as a remote sensing. Satellites into polar, north to south, into polar, right, sun synchronous orbit, sun synchronous low Earth orbit, like 500, 600 kilometers, low Earth orbit. And polar means going from North Pole to South Pole, right? Low Earth orbit, LEO. The main purpose of developing polar satellite launch vehicle to put in a polar orbit. That means this type of orbit. This is the Earth and observation of the Earth. The satellite will go like this. And they are kept low Earth orbit because it has to remain near to the Earth to do the mapping purpose. For the mapping purpose there. Right? Near to the ground. Cameras will focus on that, collect all the data. That part comes here. Sun synchronous because based on the sun's direction they work. But if you look at, it can also be used to launch a communication satellite. Let's say, if you look at communication satellite, but there is a limitation of payload capacity. Right? Communication satellites, what we call here, satellites up to very small amount, not very much higher there, up to 1340 kilograms in, there is an orbit called geosynchronous transfer orbit, what is called GTO, geosynchronous transfer orbit. GTO, right, up to 1340 kilogram. Geosynchronous transfer orbit, but small size, less than 1400 kilogram. That we can launch, right? That is what comes here. And if you look at here, what I've discussed, that it has a 4-stage solid, liquid, engine there, right? So if you take here, further here, what is second thing here? 4 stages. Launch vehicle, 4-stage launch vehicle. So first and third, it alternates with solid and liquid fuel. Stages are, they use solid propellant and second and fourth stages. That uses the liquid fuel, liquid propellant. Right? So it alternate SL, SL. Right, that's what comes here. Now there are different designs are there, different configuration. Three important configurations which comes here, and I'll explain with the diagram here about PSLV. So first thing is that the first one is just simply called standard model, core alone. Core alone. That means there is no step-on motor. Right? The first thing comes here, core alone. That is a without. There is a motors which are strapped in the first stage of the rocket. That is not used here. To give additional boost, that they use strapped. Here, there is no step-on motors. Without any step-on motor. Motors or boosters. Right? Now second one, number 2. Second one, we come across standard model. Right, standard model. Again, solid, liquid, solid, liquid, standard model, standard configuration. Now, what we see in standard configuration? In the first stage, we strap small motors, what you call boosters, to give more thrust, right? So here, this is strapped. Four such strap-ons are there, right? The four strap-ons are there. Slightly more thrust it can carry, right? Now the PSLV is designed for 2 strap-on, 4 strap-on and 6. 6 one is a more heavier. If you have to launch heavier, 1750 kilogram, 1750 kilogram, will go for XL, extra large, right? So now what comes third here? XL, 6 strap-on motors, right? 1750 kilogram payload can be launched by using this. So here you will find 6 of them. First time extra large XL was used in the case of Chandrayaan 1 mission 2008. 2008, ISRO used in Chandrayaan first mission. Then Mangalyaan mission. Then Mangalyaan mission, again we use it, and we have a 6 of them. It's all strapped around the first stage. To give a more thrust, additional thrust, right? So Chandrayaan 1 mission, Chandrayaan, then Mangalyaan mission, we use PSLV extra large, right? And you know that PSLV is said to be the most reliable, is the most reliable workhorse of ISRO. Of ISRO, because it has always the perfect launch. It doesn't fail. That's where the reliability comes with this particular space rocket there, right? That's where the reliability comes with the space rocket there, right? Now I'm coming to GSLV. Let's understand India's launch vehicle thing, GSLV thing here, geosynchronous satellite launch vehicle. So now I'll be discussing about GSLV rocket. Geosynchronous satellite launch vehicle. Again, you can get question in the comparison of the launch vehicle technology also there. What is the difference between PSLV and GSLV? Even that can be asked, right? Now, if you look at normal part of this rocket, is a heavier rocket. It has been designed for 3 stages. Designed for 3 stages. First stage for solid, second stage for liquid, and third stage for cryogenic engine. The purpose of developing this rocket GSLV, that is in terms of taking the heavier communication satellite. So what is the first thing here? Developed to launch heavier communication satellite, like GSAT, inside GSAT series communication satellites. Up to 4,000 kilogram or 4 ton into geosynchronous transfer orbit. Geosynchronous transfer orbit, GTO. Which help us to maneuver satellite into the geostationary orbit, right? GTO. But in the lower orbit, we can carry double the payload up to 8,000 kilogram or 8 tons into low Earth orbit. That also we can be done with the GSLV. Now here, what is thing here? 3 stages, right? First stage, use solid fuel. Just similar to PSLV, STPB. Second stage, we are using a liquid fuel, liquid propellant, again very similar to PSLV. And the most important part is the last stage, third upper stage. That's where we have a cryogenic engine. What do you mean by cryogenic engine? Is an engine which store, right, fuel at very low temperature, extremely low temperature, where the hydrogen gas is stored as a liquefied hydrogen, liquid hydrogen, and oxygen as a liquid oxygen, and then they are burnt there to produce the thrust. So cryo means extremely low temperature. This technology we have borrowed from Russia, but we have now developed our own indigenous cryogenic engine by a ISRO center called LPSC, Liquid Propulsion System Center, Mahendagiri. There we have developed. So here, cryogenic engine, that is a liquid hydrogen burnt with the help of oxygen to produce the thrust. Right? Now, based on the design aspect, we have again 3 configurations. Out of that, the first configuration, Mark 1, we are right now not using it. Whenever we have to launch a satellite up to 2,000 kilogram, we can use PSLV extra large, EXL, right? But yes, GSLV Mark 2 and Mark 3 we are using. So first thing comes here, GSLV MK1, Mark 1. Here up to 2,000 kilogram. But now we have replaced it. Because if you have to launch up to 2,000 kilogram, we can prefer to use PSLV extra large, XL. Cost will also be less here. Now this is just simple design. Solid, liquid, cryogenic. Right? Now what is second here? Second we have Mark 2. Mark 2. Here up to 3,000 kilogram, but 2,500 kilogram. But I'm writing here maximum 3,000 kilogram. Now what is here the design aspect? We use here booster, step-on motor. In the first stage, where we have a solid, liquid, cryogenic, here we use 4 stepper motors in the first stage. The 4 step-ons are there, right? And now comes the heaviest, what is something called fat boy, heaviest, Mark 3. We have used for Chandrayaan mission, Chandrayaan 2, Chandrayaan 3, even for Gaganyaan mission, human space flight, GSLV Mark 3 as LBM3. launch vehicle Mark 3 will carry the crew module with human astronaut inside. So here, third GSLV Mk3 Mark 3. Now it is the heaviest, 640 ton. So if you have to take to GTO, geosynchronous transfer orbit, you can take the payload of 4 ton. But if you have to carry into low Earth orbit, so we can carry up to 8 ton, that is 8,000 kilogram. So here, if you look at design here, 640 tons capacity. Now this is liquid core engine, L110. Now this is the cryogenic engines. And it has got two very heavy solid booster. It carries two heavy solid boosters. This is a design of GSLV Mark 3. So you have a S200. S means solid, 200 means 200 ton. L liquid, 110 ton liquid fuel, and CE cryogenic engine 25 ton. So 200 ton, just like a rocket, a very heavy booster. Two boosters are there in LVM3 and GSL Mark 3. Then, so once it takes off, lift off from Sriharikota, our launch pad, so this two booster goes up and then they separate and comes down. Then the liquid engine L110 starts separate. Then finally cryogenic engine. So this is a very different design, right? Two solid boosters, heavy boosters are there. Right? Then liquid core engine, L liquid core engine, L110, and followed the last their cryogenic engine. CE25 cryogenic engine. It's called Fat Boy, 640 ton, which weighs thousands of elephants. And now not only we have launched Chandrayaan 2 mission, Chandrayaan 3 mission. For Mangalyaan we use PSLV extra large, but for Chandrayaan 2 and 3, GSLV Mark 3. And now it's a LVM3 version. We are going for Gaganyaan mission, human space flight. So that is another very, very important thing which we are trying to cover from the exam point of view, because such kind of things becomes really very, very important from both kind of exams, not only UPSC exam, but even the state level exam will be important. That is comes there. Now with the demand of rockets or to launch small satellites, right? ISRO recently developed SSLV. So now let's look at here SSLV. Small satellite launch vehicle. Now what is here? It is meant for meeting the need of the small satellite to be launched and space market. India can earn more money by launching small satellites of the foreign or customers. So here if you look at, it has a solid, then again solid, all solid, and then a small one, what is called here VTM, velocity trimming module, to reduce the speed here. Now this is the model of small satellite launch vehicle. Now here, first thing here, developed by, we have now a new company called New Space India Limited, NSIL. And now we are trying to bring the private players into the space technology here. NSIL. This is a government company, right? Developed by New Space India Limited, right? To launch small satellites. Small satellites like such as what is something called nano satellite. 1 kilogram weight of kilogram, weight the nano satellite, 2 kilogram, 5 kilogram. Then micro satellite, right? Mini satellite up to 10 to 15 kilograms, and a small satellite up to 100 kilograms. So small satellites here, right? And this all can be launched into low Earth orbit. We can go for the low Earth orbit. Now, so this rocket, right? If you look at payload, maximum payload of 500 kilogram, and where we can launch and can be launched up to 500 kilometer, and we launched to orbits up to 500 kilometers maximum capacity, up to maximum 500 kilogram total payload of the satellites, right? And also up to 500 kilometers. Now, what is so unique here? It has got 3 stages, right? Solid, what you can see, first, second, third, solid fuel or propellant, and right, velocity trimming module is a very small module, velocity trimming module. What you call VTM. So actually, it is basically 3 stages rocket, but at the last, it can be, the speed can be reduced by using velocity trimming module. And what is the purpose of developing this small satellite launch vehicle? To cater demands of launching small satellites. What I've written, the first point here, small satellites, and this could be private company satellite here, private company, or sometime foreign companies, right? Foreign countries satellites. So the purpose is to get more and more share in the space market, to earn revenue, income there, and increase our share in the space market. That's the purpose of developing the small satellite launch vehicle, right? I hope you are able to understand all these points. So in this session, we have covered launch vehicle technology. So what is launch vehicle? What is launch vehicle technology? Types of launch vehicle technology, and then from India's perspective, PSLV, GSLV, and RLV. So we will again continue with our discussion in the next session with the new technology from space. Till then, remain connected. Thank you. We will meet soon. Thanks a lot.